In this problem, a mass of 23 kg is accelerating down an incline as shown in the diagram below. So the incline is 60 degrees. The coefficient of friction between the mass and the incline is 0.4 μ(k). And we are asked to calculate the acceleration of the system. So first we are going to visualize by drawing a free body diagram for the object that is in motion. So when we draw a free body diagram, we have to specify the x and y coordinates. This step is really important because we are working with vectors. So a vector has not only a magnitude but also a direction. So positive x-axis and positive y-axis. So x-axis is along the inclined plane and y-axis is perpendicular to the inclined plane. Whenever you do a question in chapter 4, 5, and 6, make sure to start the problem by drawing a free body diagram. So in the free body diagram, you should show all the forces acting on the object of interest. In this case, the object of interest is the mass of 23 kilograms. So now if you look at the forces acting on that object, weight is acting directly downwards. Weight is always acting directly downwards. And then there's a normal force because the surface is pushing the object perpendicular to the surface. So that is the weight acting directly downwards. And then the normal force perpendicular to the surface. And read the question again. The object is accelerating and there is a friction force between the surface and the object, right? So it's moving downwards, which means friction should act up the inclined plane because friction always opposes the motion. In this case, it's kinetic friction because the object is in motion. Now, those are the three forces acting on the object. And let's understand the angles. So the angle of the incline is 60 degrees. And this angle, the angle between the weight and the y-axis is also 60 degrees. You can see the right triangle here, and then 60 degrees is the angle between the weight and the y-axis. So W weight is equal to mg. Mass of the block is 23 kilograms. And we know the coefficient of kinetic friction, 0.4. And now I'm going to resolve weight into two components, one along the x-axis and the other one along the y-axis. So you need to know how to draw the vector triangle. So this is a right triangle, as you can see. The y component of the weight is parallel to the y-axis, and that angle is 60 degrees. And from trigonometry, the y component is equal to mg cosine 60, and the x component is mg sine 60. Now let's see the applicable concepts. So for this, this is based on chapter 5. So section 5.1. And coordinate system is defined, and in symbols of what we are trying to find, we are trying to calculate the acceleration of the system. And since the object is moving down the incline, we expect a positive sign for the acceleration based on our specified coordinate system. And now let's plan a solution. So as you can see, I'm going to plan my solution by looking at the x and y component of each force acting on the object. And let's start with the normal force. Normal force does not have any x component. The y component is positive based on the coordinates, and then kinetic friction force is negative, and then the weight has an x component and a y component. As you can see, the x component is positive, mg sine 60, and y component is negative based on our coordinate system, mg cosine 60. Now let's identify the equations. So we are going to use this equation for the kinetic friction. Kinetic friction is equal to coefficient of kinetic friction times the normal force. And the net force acting on the object is equal to mass times acceleration. This is Newton's second law. I'm going to use the component form of the Newton's second law. Net force in x direction is equal to mass times acceleration in x direction, and net force in y direction is equal to mass times acceleration in y direction. Now we have planned the solution. Once you have a plan, it's really easy to execute it. All you have to do is use Newton's second law in x direction and y direction, and when you do that, go back to the chart and look at the forces acting in each direction. So if you use Newton's second law in x direction, you can see I'm going to use it for the y direction first. If you use Newton's second law in y direction, you have normal force minus mg cosine 60 is equal to, it is 0 because there's no acceleration in y direction. Object is not moving perpendicular to the inclined plane. It's moving along the inclined plane. So normal force is equal to mg cosine 60. And we know that kinetic friction is equal to coefficient of kinetic friction times the normal force, and normal force is equal to mg cosine 60. So we get an expression for the kinetic friction. Now I'm going to use Newton's second law in x direction. Kinetic friction plus mg sine 60 is equal to mass times acceleration in x direction. Since we're trying to solve for the acceleration in x direction, I'm going to separate it, and I get an expression for the acceleration in x direction. And Fk is, we have already solved for Fk in terms of mu k, mg, and cosine 60. I'm going to substitute it here for the kinetic friction. Divide that by the mass m, and you can see mass is common in all the terms, so you can separate out mass from the numerator and then just divide each term by m, and then once you do that, you get acceleration is equal to g sine 60 minus mu k g cosine 60. Because m is common for all the terms in the equation, and you can divide the numerator and the denominator by m, and once you do that, you get g sine 60 minus mu k g cosine 60 is equal to acceleration, and when you solve for the acceleration, you get 6.53 meters per second. So you can check and evaluate. We got the correct units, meters per second squared. The magnitude of the answer is reasonable. Pay attention to the steps. That is the most important thing. You need to see how I approach the question. I started by drawing a free body diagram, and then I identified the x and y component of each force. And then I used Newton's second law in x direction and y direction. And after that, I calculated the acceleration of the system. I got 6.53 meters per second squared.